Hello everyone, welcome back to Success Mantra. Today we will see a new topic in chapter 1 real numbers, that is revisiting rational numbers and their decimal expansion. We have learned about rational numbers in video number 1, that is rational numbers are the numbers that can be expressed in the form of p by q, where p and q are integers and q can never be 0 because any number divided by 0 will become infinity. And there are two decimal expansions for this rational number. One is terminating and the other one is non-terminating. If you look at 11 divided by 10, it is 1.1, so it terminates. But in the case of 20 by 3, it is never ending, 6.6666 like that. Such numbers are called non-terminating repeating rational numbers or recurring rational numbers. Consider three numbers. 1.1 can be represented as 11 by 10, 3.25 can be represented as 325 divided by 100, 2.448 can be represented as 2448 divided by 1000. So what we have observed from this three representation is that if the decimal expansion is terminating, then the denominator of the corresponding rational number can be expressed as the powers of 10. That is 1.1 as 11 by 10, 3.25 as 325 divided by 10 square, 2.448 can be represented as 2448 divided by 10 cube. On further simplification, we can see that their simplification comes as 1.1 as 11 by 10. That is, there are no common factors between these two other than 1. So 11 and 10 are co-primes. Moreover, 3.25 can be simplified as 13 by 4. 13 and 4 are also co-primes. 2.448 can be simplified as 306 divided by 125. They are also co-primes. That is, if the decimal expansion is terminating, then the decimal number is a rational number and the same rational number can be expressed as p by q, where p and q are co-primes. Moreover, the denominator after simplification is expressed as powers of only 2, only powers of 5 or both. In the first, 11 by 10, 10 is 2 into 5. 13 by 4, 4 is 2 square. 306 divided by 125, that is 5 cube. That is, the denominator will be either powers of 2, powers of 5 or both. This led to the development of a theorem, that is, let x be a rational number whose decimal expansion terminates, then x can be expressed in the form of p by q, where p and q are co-primes and the prime factorization of q is of the form 2 raised to n 5 raised to m, where n and m are non-negative integers. There is also one more theorem, that is, let x is equal to p by q be a rational number such that prime factorization of q is of the form 2 raised to n 5 raised to m, where n and m are non-negative integers, then x has a decimal expansion which terminates. This is just the reverse of what we have proved before. Let us take a number, that is 306 divided by 125. It is a rational number of the form p by q. The denominator can be expressed as 125 as 5q. In order to get this form 2 raised to n into 5 raised to m, we multiply it with the missing term, that is here 2 is missing, and we multiply it with 2 with the same degree of 5. So 5 cube into 2 cube, multiply the numerator also so that the value won't change. That is equal to 2448 divided by 5 cube into 2 cube. We know that a raised to n into b raised to n is equal to ab raised to n. So we can express it as 2448 divided by 5 into 2 the whole cube. That is equal to 2448 divided by 10 cube, which is equal to 2448 divided by 1000, that is equal to 2.448. So hence we prove that if the expression is of the form p by q and the prime factorization of q is of the form 2 raised to n 5 raised to m and n and m are non-negative integers, then x can be a decimal expansion which terminates. If you want to get simplified rational number, multiply the numerator and denominator by the missing term with the same power present in the denominator. Then the result will be terminating. The next theorem is that let x be p by q is a rational number such that the prime factorization of q is not of the form 2 raised to n, 5 raised to m, where n and m are non-negative integers, then x has a decimal expansion which is non-terminating, repeating or recurring. That is, the rational number is p by q form, where q is not of the form 2 raised to n, 5 raised to m, then the decimal expansion is non-terminating. Let us see this with an example. 20 by 3, it is a rational number because 20 is also an integer, 3 is also an integer. So it is a rational number, and moreover 20 and 3 are co-primes also. But the prime factorization of 3 is not of the form 2 raised to n, 5 raised to m. because 3 has only prime factors 1 and 3. So it is not of the form 2 raised to n and 5 raised to m. Therefore, the decimal expansion to 20 by 3 is non-terminating repeating. We know that when dividing this, we get how we will get 6.6666 like that. It is not terminating repeating, that is recurring. Thank you for watching my videos, and the next video I will come back with more problems in rational numbers and their decimal expansion.